Hello everyone, welcome back to Comment Made Easy, and I hope you all are doing very well. Before we begin, let me remind my dear students that the contents of this channel are only to supplement your knowledge, not to replace the regular online and offline classes in your institution. So please attend your classes and do not miss them. Also, if you like our contents, please subscribe to our YouTube channel, like the videos, and share these videos with your friends, with your batchmates, with your juniors. Also, if you are a teacher, then with your students. Please follow our Facebook page, and the link will be given in the description. Let us continue our discussion on probability sampling with the next sampling technique, that is systematic random sampling. Systematic random sampling is most suitable for a population that is large, scattered, and heterogeneous. We know when the people in the given population share characteristics which are very similar to each other, we can consider it as a homogeneous population. But if the characteristics in the population, among the people in the population, are different from each other, that means they are not very similar, in that case it is a heterogeneous population. And for any heterogeneous population, systematic random sampling is a better technique as compared to simple random sampling. To begin with, we must have what is known as a sampling frame. We already know that sampling frame is the complete enumeration, or you can say enlisting, of all the people in the given population from which we are going to select our samples. So all the people in the given population must be enlisted. There must be some kind of list where all the people in that given population are mentioned. So that is our sampling frame, and it should be available. Sample units are selected from a population at a uniform interval by selecting one unit at random and then selecting additional units at an equal interval of its measurement. So first thing that we have to do is we have to select our first sample randomly from the sampling frame. Then we have to select subsequent sample adding a particular interval to each sample. Now it may sound a little bit complicated, but when we shall give a suitable example, it will be easier for us to understand. Now we just mentioned that a particular gap or interval has to be maintained in between samples which are being selected. This gap or interval is known as sample interval or sampling fraction, sometimes denoted as the letter small k. So what is sampling fraction? It is basically total population size divided by the sample size desired. So whatever is the size of the population from which we are drawing our sample, that has to be divided by the sample size. So from the sample size calculation, we know how many samples we need for our study, and that is our denominator. So we can say k is equal to capital N by small n, where capital N is the size of the population and small n is the desired sample size. So what are the steps of systematic random sampling? First, we need to number the sampling units in the sampling frame from 1 to n. N can be any number. So total number of the population. So if there are 1000 people in a given population, first person will be given number 1, second person will be given number 2, third person will be given number 3, and the 1000th person will be given number 1000. So that means each person, which are obviously the sampling units, will be given numbers, and that will comprise the sampling frame. Next, we have to determine a point or the starting point. The starting point will be any randomly chosen number between 1 and k. In our previous slide, we know what is k. So this will be a number when we divide the total population size by the sample size. Next step is we have to select any number between 1 and k. So this k can be 50, maybe 70, maybe 20, whatever. So if suppose this is 50, so we have to select any number randomly in between 1 and 50. And that random number can be anything like 25, 37, 49, anything. After that, every kth value must be drawn until the total samples have been drawn. So after selecting the first sample, we have to add the kth value. Again, we know what is k. This value has to be added to get the next sample. And then we add the k value again to get the next sample. And this procedure will be continued until the desired number of samples have been obtained. So the first sample is any random number between 1 and k. So when we have a list and we select any random number between 1 and k, that will be my first sample. Then we add whatever is the number that we had selected here. That is my first sample, and we add k to that. That is my second sample. And then we again add k to our second sample number. That will be our third sample. We add k to the sample number 3. That is our fourth sample, and this will go on. Since the first unit is selected randomly here, and then systematically every kth unit. So after selecting the first number randomly, we are adding k to the previous value to get our next sample. So that is why it is known as systematic random sampling. Here I have given the example which I also gave in our previous video on simple random sampling. Suppose there are 200 students in the class and we need to conduct a short survey on them. We decide that a sample of 20 students should be sufficient for this purpose. So the population size is 200. So 200 students. From these 200 students, I have to draw a sample of 20 students. So my sample size is 20. So capital N equal to 200, small equal to 20. So k is capital N by small n, that is 200 by 20 or equal to 10. So this is my sampling fraction or sample interval. So this k value is 10. This is important. We select our first sample randomly in between 1 and k. Here the k is 10. So any number between 1 and 10 is selected randomly, and suppose the first random number that we have selected is 7. Okay, so the 7th student, remember we have 200 students, so we have also a sampling frame where every student has been given a particular number, any identification code. That can also be their roll numbers. So the 7th roll number student is the first sample. Alright. The subsequent samples will be selected as 7 plus k, 7 plus 2k, 7 plus 3k, like this. So the first sample, the randomly selected number is 7. So the 7th student is my first sample. Second sample is 7 plus k, and k was 10. So 7 plus 10 is 17. So the 17th student, or we can say the roll number 17, is the second sample. Then we add the k value, that is 10, to the second number, that is 17th. So we get 27th. So like this we shall get all these roll numbers. So 17th, 27th, 37th, 47th, 57th, like this up to 197th. Let us count how many samples we have gathered. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and the 7th student is my first sample, that is 20th sample. So as you can see, out of 200 students, which is my population, I am able to draw a sample of 20 students, and these are the students which are my samples. This is a pictorial description of how systematic random sampling is done. So we can see we have 9 people, and out of this 9 we have to select a sample of 3. So the k is capital N by small n, so 9 divided by 3 is 3. So our sampling fraction is 3. First step, we have to select any number randomly in between 1 and 3. So 1, 2, 3, we have 3 options. Maybe in this example, we have selected the number 3 as our first sample. This number was drawn randomly. Then we have to add the k to this number 3. K was 3, so 3 plus 3 is 6. So the 6th person is our second sample. And then we again add the k value, that is value 3, to the number 6. So 6 plus 3 is 9. So the 9th person is my third sample. So like this, we can say from this given list of population, we have number 3, number 6, and number 9 as our sample. So that is how we select a sample of 3 people from a population of 9 people. Now, what are the advantages and disadvantages of systematic random sampling? It is easier to draw samples, and also all sampling unit have equal chance of being selected, because the first sample that we are drawing was being drawn randomly, right? So all the sampling unit in the given sampling frame have equal chance of being selected. So that means the law of probability is being maintained. What are the disadvantage? Number one, number of possible samples is greatly reduced. So suppose I have 200 students, out of which I have to draw 20 students. When I conduct my simple random sampling and draw 20 students, after that there is no way we can increase the number of samples from this given population, right? But if we were doing simple random sampling, we could have taken 25, 30, whatever number of samples that is needed. So that means once the systematic random sampling procedure is completed, we cannot draw any further sample from the population, because the k, that means the sampling fraction value, is already finalized. Number two disadvantage is sample exhibit a pattern or periodicity. So once we select our first sample by randomly selected any number between 1 and k, after that we already know who will be my second sample, third sample, fourth sample, like this, because we know that we have to add the k value to the subsequent sample numbers to get our next samples. So that means it always exhibits a pattern or periodicity. So that is why you can say it is somewhat guessable. You can guess, or predictable, you can say. You can predict who is going to be my next sample. So these are the disadvantages. So this was a very short video, and I hope you like the video. Please subscribe to our channel and share this video with your batchmates, juniors and friends. We also have our Facebook page that you can like and you can follow. The link is given in the description. Thank you, take care, and we shall see you in our next video.